Good evening to everyone. Okay. So yesterday there was a question about the NER, and you might be thinking that there is a numerical also of this one. And there is a Solas regulation. So the numerical which is done, that is with the calculation of the FLA. Okay, and that is coming also in the exam, but that is the question from the DT hall. If you see the DT hall, it is given in there. So how to calculate this NER? Let's see about this one. Generally on-board shape, NER is used to find out where the insulation breakdown is happened. So it is going to protect the generator winding due to that. Of course, there will be disconnection that will be there, but it is also going to protect the winding. Okay, and that's why this NER is put. Now, how to calculate this one? Basically, this NER we are using, this is a two methods. One is the low resistance method. And second is high resistance method. Low resistance is not used on board ship. Only the high resistance, this is being used. In this one, suppose we are having, just for example, we are having 4.16 kV system. And there is a ampere that it is going to be 400 ampere. We need to calculate the line to neutral voltage because there will be a neutral. Then only we can put the NER. Like suppose these are the winding. So we are going to put the NER from here. So this is how we are putting the area. Okay, this is the area. So we need to calculate line and neutral, means the center position, neutral. So when we are going to calculate this one, this will be 416 kV divided by √3. So this will come near about 2400 volt. Now total ampere, that is a 400 ampere, that is there. So in that case, the resistance, required resistance, it is going to be 2400 upon 400. So this will come like this, 6 ohm. Okay, so here we are taking the AFLA. So this is how we calculate with the AFLA. This is for the low resistance. So this is, I have given this one. This calculation is there for the low resistance, and same calculation it is given in the DT hall, and there is a one numerical in that it has been calculated in that way. Now, if there is a high resistance, okay, so that is high resistance, and generally we use the high resistance type only. Now, if the high resistance we are going to use, in that case, we will be taking not the FLA, but the minimum current should flow, and that's supposed to be 5 ampere, not more than this. This is the minimum current that should flow through the NER. So suppose if, again for the example, if we are going to have the 480 volt, that is the system. So again, we can calculate this one line to neutral voltage. These all are the three-phase systems. So neutral voltage, this will be 480 volt divided by √3, and it is going to give something 277 volts, near about this. Now, the required resistance, that is the NER, so this is going to be 277 divided by 5. So it will be 55.4. So this is the, now what the solar says. So solars, if you go for the chapter 2, I hope chapter 2, this one, yes. One. Okay. So solars is the chapter 2 dash 1 part D. There is a regulation regarding electric shock, that is a 45. So in this, if you go through the para 4.3.2.1. Okay, this is the para. So I am writing that one, what it is saying. That it says power supply control circuit and instrumentation circuit where technical technical or safety regions preclude means exception, preclude the use of a system with no connection to earth, provided the current in the hull is limited to not more than 5 ampere in both normal and fault condition. Fault condition. Or there is many other things are given. So this is talking about this, and this is the for the tanker. It is saying that earth distribution system shall not be used in the tank. And where it is saying about the exception for this one, there is an exception. If it is going to be used for the technical or safety regions, and we are using some control circuit or instrumentation, in that case, a system with no connection to earth, provided the current in the hull is limited to not more than 5 amperes. So this is the regulation. So again, this 5 ampere is coming, and that's why our NER, which is being calculated, it is calculated with the 5 ampere and not with the full load ampere. That means we need to put a high resistance NER. Okay, hope it is clear.
Yes, sir.
Okay. Now, this question is generally it is asked by the MMD Calcutta, and that is by the Mitra. Okay.
Yes, sir.
Now, if someone is going there, then try to see this one. This is the he is asking. Okay. Now there is a calculation also. So I'll be just putting that calculation. So you can calculate for different voltages also. Okay. So here, I hope I can increase this one. This side I can't increase. Okay. But you can see. I hope you can read this one. So this is the calculation. This is how you can calculate. So here same thing is done. This is the line voltage. This is calculated the phase voltage divided by √3. So this becomes your phase voltage, line to neutral, that is same. Current is taken 5 ampere, means like if there is a 380 volt, 3-phase supply is there. In that case, we supposed to go for line to neutral. That is also known as a phase voltage. So this one will be 380 divided by √3. Okay, so this will give approximately 219.4. Now you need to divide this one with the 5 so that NER, you can get the value of the NER, that is the 219.4 divided by 5. So this will come 43.88. The wattage also you need to calculate. If you calculate the wattage, then the wattage of this one, what should be the wattage of this resistance? In that I square R. Okay, so I square you need to take 5, so that will be 25 and into 43.88. So this will come about 1097 like this. Okay, this will be the wattage of the resistor. Okay, so everything is given here. Just go through this. So this is how you can calculate. Okay, hope it is clear.
Yes, sir.
So we were having, I think we are seeing what steering gear. Okay, so let's go through this. So yesterday already I have completed this one. Now there is a two things that is left and that questions that comes. So we will see steering gear, that is the electrohydraulic steering gear. Now electrohydraulic steering gear. So there is some basics I will just cover because sometimes they are asking about this one. Okay, so here basic electrohydraulic steering gear system. Now, this is a very basic electrohydraulic system. Now, how it is going to work already we have seen. That is autopilot, how it is sending the signal. Now here, in this case, we are going to use a hydraulic pump. The symbol is already given here. So this is the pump symbols, which is going to take the suction from the hydraulic oil tank. And it is going to provide a pressure here. That is the working pressure. So that is given here 80 bar. Okay, so there is the pressure 80 bar that is given. Now it will be through the directional control valve. Now this is known as a directional control valve. This is solenoid. Yeah, it is written here also solenoid operated directional control valve, which is going to provide a pilot pressure to the main directional control valve. This is a pilot pressure operated. So this is a main directional control valve. This is a pilot pressure operated. Now there is a symbol to understand this one. Now you can see here there is a triangle. So if this triangle is there and there is a dotted line, that means this is a pilot pressure that is applied to this one. Okay, and here there is a slant line you can see here. This slant line that symbolizes that it is a solenoid operated direction control valve. We are going to have a pressure reducer which is going to reduce the pressure about, you can see here, pilot pressure, that is the 4 to 5 bar. So 4 to 5 bar, that will be coming to the P. This is the pressure point. T is always connected to the tank, that is the T. A and B is a power port. Now, direction control valve, if you know about that one, okay. And there is a symbols that is used in this, and you must aware about this also. This is known as a spool. In the spool, here it is the center. It will be always, this spool will remain at the center because both the sides it is going to have the spring. So this is the symbol of the spring, which is connected to the pressure of the pump, that will be known as a P port. The return line which is connected to the tank here. So this is the symbol of the tank. So it will be connected, it will be written here T. T. This is a tank. This is the symbol of the tank. And here it is written A and B, which is given to the ram cylinder from here. So this is known as a power port. Ports. So this is the P port, the T port, A port, B port. So we have the 4 ports in this. Okay, this side you will find there is a arrow like this it is. And this side you will find there is a arrow that is in the cross. So this is the mid position, and we have the 3 more position. So this is going to be, suppose this is the position 1, this is the position 2, and this is a position 3. So it is going to be always in any one position, always it is going to be. Okay, so 1, 2, 3. So 3 positions. So this is known as a three-way valve. Three-way valve. And that's why we say 4 by 3-way valve. So this is the reason it is having the 4 port and 3 position. Okay, so 3 is the position. 4 ports and 3 position. So 3 position, 3-way valve. So this is also known as a 4 by 3-way valve. Now this can be activated either by the pilot pressure, electric signal, or manually. So there is a symbol that is going to be used. If it is operated by pilot pressure, there is going to be a triangle in this. So this triangle means the pilot pressure is applied to this one. In this also it is going to be operated, this directional control valve. Okay. If it is solenoid, then it is going to have a line like this. That means it is also a solenoid operated, pilot pressure operated, and the solenoid operated. If it is going to have a handle like this is the manually operated. So this is the manual. This symbolizes solenoid operated or electric signal is required, and this symbolizes pilot pressure. When pilot pressure or solenoid or manually we are doing, okay, so basically this spool will move and it will come to the center position. So if this spool is moving, suppose this spool is moving, it will come to this position here like this. Okay, it is going to shift, entire things will shift. So now pressure is applied to the A point. So P is connected to the A, And if you see this B, this is connected to the T. That is, pressure is applied to the A port and B is connected to the return line. When this solenoid is energized or this side pilot pressure when you are giving, in that case, it is going to be cross. So this cross will come this side. This cross will come here. So now, in this case, this P is connected to the B and A is connected to the T, like this. That means now direction is changed. If anything we are having here like ram cylinder or there the van type rudders or any types, like we have the hydraulic motor, okay, their direction is going to change. And that's why this is also known as a 4x3 way directional control valve. The direction is going to change. Okay, so this is the just brief idea I have given you about the direction control valve. How it looks, I will just show you. There is a one diagram is also, one picture is there. So you should be aware if any question they are asking, because they are asking, these all are the stupid questions. This they should not ask to the electrical engineers, but they are asking. This is the same thing what just now I have drawn 4x3 way, but it is only the solenoid valve. It is operated by solenoid. Now the symbol you can see only the one line is there. That means it is solenoid operated only. You can see there is the solenoid that is connection that will be given. One is this side and one is the other sides. We are having the armature, that is the winding, and this is the armature. So this is going to move to this side. Once it is energized, this will be moving. This center one, this is known as a spool. So this spool is going to be pushed this side, means this direction. It will be pushed this direction. Now it is in the center position. And if it is not energized, it will remain in the center position. In that case, your T port and P port is blocked, whereas A and B is also blocked in this case. So all are blocked. So you can see here A, B, P, T, all are blocked. Okay, center position. Now suppose this is energized. If this is energizing, then spool is moving this side. If it is going to move, then the P, this is the pressure port, this will be connected to the A. And this B, because this B is return line. So from here, like this, because this will move this side. So it is going to connect it to the T. Okay, so B will be connected to the T. So likewise, it is going to connect. If you can see, if you are energizing this side solenoid, suppose this solenoid is being energized. So in this case, the spool, this spool is going to move to this direction because this will be moving to this side. So this spool is going to move in this direction. If it is moving in this direction, then P pressure point port that will be connected to the B and A, this will be connected to the T. Okay, so your direction is changed. And that's why this cross arrow is given. Okay, so this inside one is a spool and this is the solenoid parts, solenoid operated, solenoid parts are there in that one. And this is how it works. Okay, I hope it is clear. There is one more picture is there. I also would like to put that one, and that is this one. This this is how our electrohydraulic system, where we have the directional control valve, this is stacked together. So stacking together, that is, we are having the directional solenoid operated direction control valve, that is this one. It is also written pilot valve, but it is solenoid operated. Here you can see the line. Okay, so this is a solenoid operated. Here you can see the triangle. So the pilot pressure, you can see this is the small pressure that is going here. And which side this spool is moving. Suppose it is moving this side, it is pressurized. In that case, this is the pilot pressure that will be applied through this to this spool. So this spool is going to move in this direction. Okay, this is how it works. So this here now there will be the this is through the reducer. So main pressure, that is if it is moving this side, the main pressure, that is the P main pressure, this will be applied to the P, and A pressure, this will be connected to the T. Okay. So you can see here, this is how these all things are work. So this is the main valve, and this is the pilot valve, and this is a solenoid operated, whereas this is a pilot pressure operated, a small pressure operated. So this is how it is stacked together. You might have seen on board ships. So this is the same diagram. It is splitted here. I have to split because I need to tell you how it is working. That's why. Otherwise, these both are stacked together, but they are separate. Okay, solenoid operated DCV that will be on top of the main DCV, direction control valve. Okay, now let's see how it is going to operate. Then what happens, suppose if we are going to be in the NFU control lever, or we are going to be in the AFU mode. AFU mode, your servo control amplifier, that is going to give, and this is the NFU mode. Whatever the mode is selected, this one of the solenoid that is going to be operated. Now suppose this is operated, we are giving the port side. Now if the port is given, this is operated. If this is going to operate, here the P will connect to the A, and B is going to connect to the T. That means a small pressure of 4 to 5 bar that will be applied here. So this, because this reducer, which is going to reduce the 80 bar pressure to the 4 to 5 bar pressure. So this pressure that will be applied to this directional control valve. So this spool will move here. It is again, sorry, the arrow is opposite. Okay, P is going to be connected to the A, and B will be connected to the T. So now this pressure, 80 bar pressure, now this 80 bar pressure that will be applied here at this point. This is going to move the piston, and once this move is piston is moved, the tiller is going to move, and it is going to rotate the rudder stroke, because this will be moving. So rudder is going to move in the this direction. This is the direction rudder stroke is going to move. Return line, because this piston is moving, so this side oil is there, that will be returning back like this through the B. It will be coming back, and it will be going to the tank. Okay. Now, if suppose we are going to operate the starboard, now suppose this is the STBD starboard. If the starboard is operated, in that case, what will happen? This cross, so that P is going to be connected to the B, and A will be connected to the T. So a small pressure, 4 to 5 bar, that will be coming pilot pressure to the main directional control valve. Here also same thing will be there. P is going to connect to the B port, A is going to connect to the T port. 80 bar pressure now, 80 bar pressure that will be coming. Okay, and it will be applied here at this. Now, if it is applied, then in that case, this piston is going to move in this direction. So the tiller will move and rudder stroke is going to turn in this direction. Return line, suppose this is the oil and this oil is will return back like this. It will be connected A because A is connected to the T and this is going to return back to the tank. This is how the electrohydraulic system works. This is a very, very basic concept, but this much is only required for the COC. Okay, only this much is required. Now, in this case, we have seen already in the regulation that they are supposed to be the pressure relief valve, any part of the hydraulic valve system. So this is the pressure relief valve. When A is pressurized, this pressure relief valve is going to work. When B is pressurized, B port, this pressure relief valve will work. For the maintenance purpose, we need to bypass both the A and B port by this bypass valve. So there will be the pressure, if any pressure is there, that is going to neutralize. Okay, so this is the bypass valve. So it will be bypassed. There is a isolating valve also. Somewhere in between, you are going to have a isolating valve. So like this, we have the isolating valve. Suppose we have the isolating valve here. And in case of any leakage, generally, we are going to isolate. In that case, we supposed to have the 4 ram cylinder types and we can isolate the leakage parts. So this isolating valves manually, it will be given. Automatic types are there, we'll see that. Hydraulic oil tank, this is going to have a low level alarm. Low level alarm. Okay, so hydraulic parts, we supposed to have pressure relief valve, low level alarm, then a bypass valve to neutralize. This is not a SOLAS regulation, but generally it is given. Okay, your working pressure should not be more than the design pressure, or your means design pressure. It should be, that is already the regulation I have told you. You can go through that one. That's supposed to be 1.25 times of the design pressure, less than that. So here you can see if the design pressure is 100 bar, then working pressure is going to be 80 bar. Okay, and relief pressure should not be more than the design pressure. So here it is 100 bar, working pressure is less than that, that is the 80 bar. So these all regulations we have talked about, you can go through that. Okay, so this is only the basic electro-hydraulic steering gear system. Okay, any doubt to anyone in this?
Sir, so there is a one question like steering gear hydraulic alarms. What are the alarms in the hydraulic system steering gear?
Yeah, we have covered already in the regulation. If you go through the regulation, we have covered all the alarms. Okay, but I'll be writing again that one here. So you can go through that. Okay, what all alarms are there? I'll be writing here. Now, if you see there is a steering gear. Steering gear alarms. So steering gear alarms are, one is the overload alarm. This is only giving the overload alarm and it is only the one equipment or starter which is having the auto OCR. Rest all the starter circuits of any motor, they are having the manual reset. What is the indication of manual reset? Manual reset indication, you will see there will be a cross in this one and it will be written OCR. And there will be a cross in this. This cross means it is a manual reset. Whereas only the steering gear system which is having the auto reset OCR. Okay, so overload alarm. That is the one. Second, phase failure. So in the regulation already it is given. If three-phase supply is there, the phase failure alarm should be given. Okay. Then in case of power failure alarm also should be given. D, there is a control power failure. This alarm also should be provided. Then E, low level alarm, low hydraulic oil level. This is also the alarm. Only these alarms are there. Okay, in the steering gear as per the SOLAS. Steering gear, alarm and trips. If you see the trips, we have only the two trips. One is a short circuit trip for power. This is the short circuit trip for power. And there is a short circuit trip for control supply. Control, system control, that is the autopilot. Okay, for control system. This is as per SOLAS. Okay, so short circuit trip only that is there for the power and control system. Okay, any doubt in this?
No, sir. Thank you, sir. And sir, there is one more question I have.
Yeah.
Uh, the in steering gear, this insulation is having a like withstand capability of 200%.
No, there
So,
already we have talked about that. There is no such regulation of 200% insulation. Yesterday I clearly told about that. There is no such regulation in any solars anywhere. I
okay, sir.
have already completed that one topic. Regulations 29 and 30. Only two regulations are there for the steering. It is not mentioned anywhere in the solars. 200% insulation. I don't know from where it is coming. I
Okay,
hope
sir.
you remember that one. It was very clearly I have told about this one. Where is that? Regulation 30. Just go through this. Here. Here. I have cleared this one. Correct? No? Para 3. Just see. We have talked about half an hour about this. It is not a 200% insulation, it is a 200% of FLA. That much current should pass. It should permit the passage of 200% current.
And sir, for this one, which type of insulation we are using? Which class of insulation?
Either B and F, yesterday we have talked about this. Just see here, insulation class, either it is B or it is F.
Okay, sir. Okay, thank you, sir.
Okay. You can check in your manual if you have the soft copy. You will find it is B or F. That is the insulation class for the steering gear motor that is being used. Okay.
Yes, sir.
Yeah. Now, next one question they are asking. That is the two questions, one question that they are including in this many things. As per SOLAS, only this much supposed to be there, not more than this. You can include in this, there is a hydraulic lock alarm. This is the one question they are asking. But this alarm is optional. It is maker which is providing, it is not as per SOLAS regulation. Okay. And there is a one more is there, that is the high oil temperature. This is the hydraulic oil temperature. This alarm that is also provided by the maker. It is not as per the SOLAS regulation. So this is not as per the SOLAS regulation. But they are asking this question. Okay, hydraulic lock alarm. Now, what is this hydraulic lock alarm? Let's see about this. This hydraulic lock alarm. Okay. Now, already I have told you about here in this diagram, if you see, if the rudder is not going to the set value for a certain period of time, then this alarm is going to activate. Okay. How it is activating? Suppose from the breeze, 5-degree port is given, command is given 5-degree port. And rudder is not going to that position. Okay, rudder is not going to that position, then this alarm is going to activate. That means there supposed to be some sensor. Okay, there supposed to be some sensor. Sensor has to be there. So that sensor is a proximity switch. Generally, it is placed in the this solenoid. So where the solenoid, this spool is going to move, it is going to sense. So we have a proximity sensor. Sometimes the proximity sensor is given to the direction control valve here. Okay. Or sometimes they are also giving here in the ram cylinder itself. Okay. Here. But this is easiest way to give in this position. Some system will find it is given here also. This proximity sensor is actually sensing the movement. Now here if it is put, it is what the movement it is sensing, the spool movement. If the spool movement is not there due to any reason, your this cylinder or this piston is not going to move because there is no pressure. Maybe whatever the reason, that pressure is not going to come and apply. So if you see this hydraulic lock alarm, so this hydraulic lock alarm that will come due to the region, below region that is there. And the region is one we can say that spool of direction control valve uh, is sticky. Okay, the movement, it is not moving. This we are talking about direction control valve, that is the pilot valve. Okay, this is the pilot valve. It is not moving. Or main valve, that also is sticky, is full of main direction control valve is sticky. In this case also same similar thing will happen. The solenoid which is operating, okay, solenoid of pilot direction control valve is inoperative. Okay, then controller of autopilot is defective. In this case, none of the signal that is going to come. The command is coming, means it is given from the autopilot, but the signal is not reaching. In this case also, same thing is going to come. Sensor. Now proximity switch itself is defective. Is defective. That means it is not going to sense the movement. And lastly, if it is a proportional valve, sometimes we have the proportional valve. Directional control valve itself is a proportional valve. Sometimes we use. In that case, if there is a hydraulic pressure, no hydraulic pressure, or hydraulic pressure is less, in that case also, it is going to be hydraulic lock alarm will come. Now this hydraulic pressure and hydraulic pressure is low. The proximity sensor, if it is there in the directional control valve, then it is going to sense only in case if the directional control valve is a proportional control valve. Proportional control valve, direction control valve is different type. In that the pressure is also used to move the spool. And in that case, your proximity sensor is in the directional control valve. No hydraulic pressure or hydraulic pressure is less. In that case, your proximity sensor is there in the ram cylinder. Okay, it's supposed to be fitted here. Then it can sense. Otherwise, it is not going to sense. Okay, hope it is clear. Okay, now next, how to test it? That is the next question they are asking, how to test. How to test hydraulic lock alarm. Hydraulic lock means hydraulically it is locked and there is no movement of the steering gear. So that's how the name has come, hydraulic lock. Testing is very simple. Switch on both the steering gear. Both steering gear. Number 1 and 2. Okay, both you can do this one. Select to the FU mode. And in FU mode, go to the hand mode. Go to the hand mode. Okay, so hand mode is also known as a override position. Override position. So you are overriding the control. Directly you are taking the control in the hand mode or manual mode. Then come to the steering gear compartment. And here you need to push. There is a manual push lever is there. Or there is a screwdriver type one. Screwdriver is there. That is a lever. Okay, so if you are going to push through that manually, manual push lever, push any side, port side or starboard side. So this pushing we are doing in pilot direction control valve. Pilot direction control. So any direction you need to push it. And after the 4 to 5 seconds, whatever the delay is there, this hydraulic lock alarm will come. Okay, this will activate. Okay, so this is how we are testing it. Now, whatever the alarm is coming, one more question they are asking in this one. Whatever the alarm that is going to come, how we reset it? Anyone? How you reset this alarm? I hope you might have reset this alarm after the testing. How you are resetting it? Nobody is knowing how to reset? Very surprised. Okay. Generally, when this alarm is going to come, this will be coming, and when it comes, it is going to uh, any alarm which is coming, either it is going to come in the nav breeze, if it is provided in that, or it is going to come in the ECR, or if there is a local position, sometimes it is given in the local position also, the alarm. Okay, so it is going to flicker. On and off, it will be there. And there is going to be this is the visual indication, and there will be the audible also. So there is a audible. So this audible alarm is going to sound. So this is will be sounding, and this you are going to have a visual diagram. Now, generally there is a acknowledge button. This acknowledge button, we press it. Once we are going to press, and if the alarm is still there, okay, this flicker is continuously, it will glow, continue glow will be there in this, and sound will be muted. This will mute. So once we acknowledge, sound is going to mute, but the glow of the alarm will be continued. So all have the different indication. So that indication that is going to glow. When it is going to become normal, it will get reset automatically. If it is not becoming normal, then it will not get reset. Once we acknowledge, thereafter continuous glow will be there. And if the alarm has become normal, it will get reset. Okay. Hope it is clear. Any doubt?
No, sir.
Next is about the isolation systems. So this isolation is what that we need to see. Okay, you can have just a small break, 5 minutes. Then we'll see about the automatic isolation.
सर वो हाइड्रोलिक ऑयल हाइड्रेट लॉक अलार्म का मेरे को सर स्क्रीनशॉट लेना है Mobin sir.
Yeah, he was saying just 5 minute break. So after that he will come back.
Okay. स्क्रीनशॉट लिया है क्या किसने?
Okay. Let's see the automatic isolation, how it works.
Hydraulic, yes, sir. Can you explain one more time?
Which one?
This hydraulic lock test.
Okay, now where did you not understand?
Sir, I don't understand here. Like first we put this follow-up mode and put into hand mode. Okay.
Yeah, okay.
Then after we come to our steering gear platform and operate this pilot valve actuator.
Yes,
Then when we put the follow-up hand mode, then how can we operate from in manual? Because it is operate from only non-follow-up mode, no?
no. In the FU mode, now
Okay.
see, when you are in the hand mode,
Yes, sir.
you are not operating anything here. Now suppose your rudder is the 0, 0 position, it will remain at the 0, 0 position, no? Because it is a override position.
Okay.
Because you are not giving any command from your hand steering.
Yes, sir.
Okay. Now
Yes.
if you are going to push your pilot direction control valve,
Okay.
that means your rudder will start moving other side. Which side you are going to give the command?
Okay, sir.
That means it will not remain at the 0, 0 position.
Yes, correct.
Okay, and that's why it will activate the hydraulic lock alarm.
But when I actuate that pilot cylinder, like if I actuate in port side, the rudder start to move on port side.
Yes,
But the hand mode is still in 0, 0 position, so that's why it's giving hydraulic lock alarm.
yeah, that's why it is given.
But
It's
rudder is moving. Whenever giving the actuation, the rudder is moving.
rudder is going to move. That means it thinks that there is no pressure or there is a less pressure.
Okay, sir. Okay, okay.
बट proximity sensor सेंस करेगा ना स्पूल को.
Yeah, it's supposed to be at the 0, because there is a command that is also coming, no? So command,
हाँ बट सर स्पूल स्पूल सेंस करेगा ना, proximity sensor स्पूल को सेंस करेगा ना.
yes, yes. This is not only one thing is there in this. It is both the things are there. Like there is a flow chart. If you know how to read the flow chart, you will understand how it actually works. Can you see here? There is a flow chart. Here. So if your motor is running, there is a hydraulic supply is there. And steer handle, starboard or port control if you are giving from the wheelhouse. Starboard and port command that is coming. Number 1 solenoid valve starboard side energized. Number 2 solenoid valve starboard side, means both the steering gear, if it is on, this will happen. Okay. Then number 1 system, for this one is number 1 system, both supposed to be there. Hydraulic supply plus the command, both supposed to come. And solenoid valve is energized. Now number 1 valve, block movement to starboard side. Yes. Proximity switch starboard side action, it will take red lamp. No, that means proximity switch starboard side, no action, not action, no action will be there. Okay. Number 1 steering gear system, hydraulic block, this alarm will. If yes, in that case, steering is normal control. In this case, what will happen now? Number 1, steering gear motor is stop. There is a push button. Okay, by operator, he is going to push this one. Number 1 steering gear motor is stop command. Number 1 steering gear motor is stop. Steering normal by the number 2. There is the flow chart for the hydraulic lock alarm. Means both the things supposed to be there. There is supposed to be the signal that is coming, and there is a proximity sensor. This also supposed to sense. Now, if the connection, if you see here, it is something like this. There is a connection. 1 minute. There is a relay in this one, and there is a connection. That connection will be there in such a way and that's why the proximity sensor that is put. Can you see here the proximity sensor? There is the solenoid A and B for number 1 steering gear, and this is for the number 2 steering gear. And there is a proximity switch. And hydraulic lock alarm relay box. Inside this, there is a relay. And when the command is coming to the solenoid and proximity switch, that's supposed to sense that. If command is given 00, that means rudder is going to remain at the 00. Okay. And proximity sensor is sensing the spool movement. That means there is something wrong. And that's why it is going to give you the hydraulic lock alarm. Hope it is clear. Okay. Okay. Now Let's see about the automatic isolation system. Automatic isolation system, generally, if it is going to be tanker of 10,000 and other ship of 70,000, in that case, this automatic or self-matic, there is a one more is there, self-matic. This automatic isolation, this is provided in the steering wheel. In this case, we are going to have at least 4 ram cylinder types, then only it is going to work. If we are having only 2, generally it doesn't work. Now here, this is the, suppose this motor is running, we'll go straight way how it is happening. Suppose this motor is running. So number 1 pump is running and there is one servo pump. Servo pump provides a pilot pressure, a small pressure. This will be provided to this valve. This is known as a bypass valve. And here we are having the auto isolation valve. So this bypass valve, which is there, it will, if pressure is not there, that means 1 and 2 is connected. Okay, it is bypass, it is connected. Once this pressure is available, this pilot pressure, they both will be separated. And they're supposed to be separated in the normal condition when they are working. And that is the work of the servo pump. My number 1 pump, that is the main pump. And suppose the command is given here like this. So this pressure P is connected here. Okay, I will make with the different color. Otherwise it will mix up. So this pressure will be applied to number 3. And also this same pressure, it is applied to the number 2 cylinder. So the tiller, this will be moving in this direction. This is the tiller, this is going to move this direction. And similar way, the return line, just see the return line. Here, the oil that is going to return like this. This is the return line that is connected, and through this side, this will be connected to the return line. And this is how the normal working condition, normal it is going to work. Now, suppose there is a hydraulic leakage. Now, suppose here there is a leakage. Okay, and it is leaking here. If it is going to leak, then what will happen? The level will go here down. Low level alarm will come. First, it is going to give the low level alarm. If leakage is severe, if it is severe, then there will be a low level alarm and trip. Okay, this trip means it is going to trip this motor. This motor will get tripped due to this one. This automatic isolation valve, this will get energized. And once it is energizing, in that case, this will separate this side and this side group. Okay, like this. So this will energize This will be on electric signal by electric signal, and it will separate the group 1 and 2. This pump will start. This is the third action. Okay, this is the first action is this. Second, if it is severe, then this will come. This motor is going to trip. D, auto isolation valve, this will be on. This pump will start, this will be E. This is the sequence. It is going to start. And now this servo pump. Now servo pump will be serving only to the group 2 because it is separated here by the auto isolation valve. So it is going to give only this side. It will be not giving in this direction. So this direction nothing will be going. So it will come to only this. So these two, cylinder 3 and 4, will be separated, and this will not be separated. This will remain connected here. This will remain connected this side. Okay, or it is bypass through this. It will be bypassed, it will be not separated. Now, when suppose same command is coming, here the command that is given, suppose like this. So the pump pressure that will be applied to the number 3, but it is not going to apply to this side. Nothing will be applied to this side. Only it is going to be applied to here. It will be not going because it is separated group. Similar way, the return line, sorry, the return line, this will be connected to here. So this is the return line. So now the capacity of the steering gear will be reduced by 50%. Okay, it will reduce by 50% because only one side, the cylinder that is working, not the in the cross, it is not working. Hope it is clear. Automatic isolation system. So this is how it is going to work. This question was also asked, automatic isolation system in the Mumbai also, MMD, and I hope Kochi MMD they have asked for this. Okay, that's it. Anything else you want to know? Okay. Sometimes they are asking one question, how we do the emergency steering operation? Can you tell me how we do the emergency steering operation? This question they are asking because everybody is supposed to know about this. Emergency steering operation.
Sir, put the autopilot in non-follow-up mode.
Okay, put the autopilot in. Pilot in. Which mode?
Sir, NFU, non-follow-up.
In off mode.
NFU mode. Okay, so someone is saying off mode. Okay. Okay, then next what we are doing?
Then we have to take the command like for the manual.
Manual command. No, where you take the manual command?
Sir, then
From
we
the steering gear compartment.
Local position, say no?
Yes, sir. Look.
To select the local position, okay. Then,
sir, where we have non-fold-up lever, sir, for starboard and port.
non-follow-up lever is there in the autopilot. It is not there in the steering gear compartment.
अरे सर एक्चुएटर वॉल्स होती है ना सर जो
Yes, that is same direction control valve, what we are talking.
यस सर
Okay. In this, you need to push manually. Correct?
यस सर
Sometimes you have a lever here. Yes, there is a lever, but manually you need to push this direction controller either by the lever or there is a screwdriver type like this. Okay, that is given. You need to push by this. Correct?
यस सर
Yeah. Okay, that is correct. One or two things I need to again put it here. One is first is the establish a communication. Okay, so communication is from the steering gear compartment to nav bridge. Either by the sound power telephone or if you have the radio, okay, portable radios, you can use that. Both can be used. Okay. Then there is a switch that is given in the steering gear compartment. Switch off control supply from steering gear compartment. I hope everybody know about this one. There is a switch that is given in the steering gear compartment. You know about this switch?
सर वो पीसीबी टाइप का एक छोटा सा बॉक्स बना होता है सर उसी में से बंद करना होता है ना
Yes, yes, there is a switch.
यस सर
And there is a regulation also this. I think this regulation, I have told you about this also. You remember this switch. Can you see here? There is a regulation for this. 8.1. There has to be a switch to disconnect the autopilot. Okay, this is a SOLAS regulation itself. And that's why we need to switch off the control supply from the steering gear compartment. If you switch off, there will be no supply to the autopilot. There is no need to change over to the NFU mode from the bridge because there is no control supply. So no supply, no control command also is going to come to the steering gear. Nothing will be coming. But generally for the cautionary measures, we change over. Otherwise it is not required. Change over to NFU mode in nav bridge or autopilot. Okay. We do write this one, but this is not required. If you are going to switch off this one, it will go automatically to the NFU mode only. Okay. And there will be no control on it. Nothing is going to come from the autopilot. D, select local position in starter. There is the remote and local, correct? There is a switch. It is
यस
off.
रिमोट एंड
Well, and this side it is remote.
यस सर
In between there is a off. So put this one to the local position. So once you put to the local, the steering gear will start, whichever the steering gear, number one, number two. Okay, one or two that will start. It is going to start. Then manually push the directional control valve, that is the actuator, what you are saying. Okay, this directional control valve to the ordered direction. Whichever the direction they are giving, in that direction, you need to push it and stop it when the rudder is reached to that angle. Okay, this is how we do the emergency steering. Okay. Okay, that's it about this. We'll see something new. Main engine telegraph. Okay, main engine telegraph. Okay, I have to tell many things in this, how it works. So, main engine telegraph. Now, when we say main engine telegraph, so basically we are talking about the control parts in this one. Now, main engine can be controlled from the local position. It can be controlled from the remote position. From the remote position, we have the ECR and also we are having the breeze. And we are also in some shape, we are having the breeze wing. Wings, port or star. Now, how this control is given? Local position is having the selector switch. For local and remote. Local, remote. And this remote is going to the ECR. Then we need to acknowledge from the ECR, and from the ECR we can do the local. Oh, sorry, remotely we can operate the main engine. Okay, so this selector switch will be always in the local position. That is engine room. Okay. Now, in the engine room, either the engine room wants to keep the remote control, okay, by itself, then it will be there in this. Otherwise, again, there is a selector switch here. In this selector switch, it can select to the breeze. So now the control has gone to the breeze. Okay, control has gone, main engine will be operated from the breeze. Or control, it will be controlled from the breeze. Sometimes during the maneuvering, in some ships, bigger ships are there, then this control also is given by the selector switch. It is having a selector switch here. And it can be given to the breeze wings, port or starboard. It can be selected. Now the main engine is going to be operated from the breeze wing. Okay. So this is about the control. Now, what is telegraph? So just remember the main engine, when it is operated from the ECR, that means we are operating the main engine remote position, or when the main engine is operated local position, that is the engine room. So this is a local. Okay, local position, or I will write engine room here. This is the local position. That time, the bridge, navigation bridge, is going to operate same. That is the engine order telegraph. That is the same handle which was used for the control. So bridge engine order telegraph, it is also a control, or we can say RPM is set in this. So this is doing the dual function. It is going to be operated as a engine order telegraph in case main engine is controlled from the ECR or local base. And if it is operated, if the main engine is going to be operated from the bridge, same EOT. Now it is not in the telegraph mode, it is in the control mode. It is controlling the main engine. So basically prime things what it is doing primarily it is setting the RPM. So for the engine order telegraph, it is having a separate potentiometer. There will be one potentiometer. For the set RPM, it is having the separate potentiometer. Okay, so when we select to control mode, this potentiometer will be selected. When it is selected for EOT, this potentiometer will be selected. Now, in case of the engine order telegraph, it gives the order to the local position and ECR parallelly, same time. Simultaneously, this order goes. Now, if the engine is to be operated from the local position, we are going to acknowledge. Again, by the EOT itself, we will be acknowledging. Or if it is from the ECR, it will be acknowledged from the ECR. Thereafter, we have a separate lever for the control. Engine control, we have the or maneuvering handle, what we say, engine control lever. We are going to operate this one either from the local position or from the ECR. Okay, so let's see how it is working. So there is a one diagram is there. I will be putting that one. We'll insert here. This is the diagram. I think I need to increase little bit. So this is the telegraph. Okay. Main engine telegraph system. Here there is a selection button. You can see either it is going to be operated in the telegraph mode or remote control. It is going to be operated from the engine control room or from the engine room. That is the local position. So accordingly, this will energize. Now how it works? Let's see the telegraph mode. In the telegraph mode, this is the EOT, engine order telegraph, that is there in the bridge. And suppose we are going to move to the dead slow ahead. Dead slow ahead. The pointer will show the dead slow ahead. The same signal that will be coming to the operational amplifier, this is the op-amp. Okay, so it will be coming to this, and parallelly it is going to come to this to EOT. Here also we have in the engine room we have the EOT, in the ECR also we have the EOT. This pointer, this is going to show the dead slow ahead. Here also this pointer will show the dead slow ahead. Operational amplifier, it is going to give the output, this K3, this will energize, this will make a contact, this buzzer is going to sound, this is the gong bell in the engine room, this also will sound. This buzzer, this is there in the ECR also, it is also in the breeze, but breeze one is not going to sound because order will be coming from there. So this will sound only in the engine room, ECR. Now we are going to reply this. Okay, I think I have written wrong here. This one I supposed to make dead slow ahead. Now we are going to reply this one. Oh, sorry. Not this. I'm making wrong here. This pointer, this will show dead slow ahead. And this pointer, this will show the dead slow ahead. Now we are going to reply this one. Let's change the color here. So suppose we are operating from the ECR, then we are going to reply from here. So we are in EOT telegraph will move to the dead slow ahead. This is the potentiometer, this signal will go. We are operating from the ECR, so this will change this side. Like this. It is in the telegraph mode. It is in the telegraph, so as it is shown. The same signal will go to the operational amplifier, and this signal will come to this motor. This is the servo motor, servo amplifier and motor both are together. And it is going to show the dead slow ahead. This buzzer, because if both are having the same signal, there will be no output here. K3 will be off, so there will be no sound in the buzzer. And the person who is giving the command from the breeze, he will come to know that it is accepted by the ECR. Okay, so this is how the telegraph mode works. This type of telegraph, which is using, it is using a servo amplifier. Servo amplifier which is going to control the servo motor. This servo motor is going to move the pointer. So very small motor is there. So this is the pointer it is going to move. There will be a feedback mechanism from here. And this feedback will be given to the servo amplifier. So this is how the servo amplifier servo motor works. It is a closed loop system again. And this is the signal that will be coming to the servo amplifier. So it will place the pointer at that position. Okay. So this is, here we use the servo motor. Many people might have seen the Linkso Marine. In that EOT, you might have seen So that EOT, it is having the servo amplifier. I hope you have seen the Linsomarine, everyone.
Yes, sir.
Yeah. So in that, you might have seen that one. Okay, so it is using the servo amplifier. Nowadays, all the EOT, they are having the servo amplifier. Some old ships, if you are going, you may find they are using the synchro transmitter and receiver. Already I have told you. So that also can be used. Okay, and some ships, they are using that also. This is the diagram. Okay, I will put it this side. This is the EOT telegraph looks like. I hope if you have seen this one, if you have worked in the Linsomarine, you might be knowing. It looks like this. So this is a pointer. This is the order pointer which we gives the order. With this shaft, potentiometer transmitter is attached. Okay, with this shaft, potentiometer will be attached. So this lever, when you move, this pointer also moves along with that, and potentiometer is going to give the signal. And this is a reply pointer. This both are fitted in the BCC, bridge control console wheelhouse. We'll not say VCC, but wheelhouse, generally we say ECR. Whereas in the local position, it is not similar way, it is little different. It is used something like this, looks like this. But working principle is same. Okay, here you can see the pointer. This pointer is there. This pointer will move to the dead slow ahead. When the command is given from the bridge, it will move here. Now this is a knob. One knob is there. This is a knob. And we need to reply by this. So this knob will be put here at this position, like this. It will be aligned with the pointer. So this is how we are replying. This is from the engine. We have the push button also. Okay, so different makers are there. As per that, we are having. So in that case, you will be having the push button. So you need to reply by the push button. That is the digital one. Okay, these all are the analog signals, and it is working as per the this one. This servo amplifier, servo motor, and this is how it is working. Okay, hope it is clear. Any doubt in this? Then the synchro transmitter and receiver, if you see here, this is already I have told you about the synchro transmitter and receiver yesterday. So olden ship, they are having this telegraph system. In that they were having the synchro transmitter and receiver. It also works in the similar way. So we are going to have a synchro transmitter here that will be attached with the handle. Once we are going to move, this will give the signal here. This receiver, so here we have the receiver pointer. This pointer will move to the dead slow ahead. With the handle, we have given the dead slow ahead. Now we are going to reply with the handle. Once we reply, this pointer will match with this one. Okay, so with the handle, if we are going to move dead slow ahead, then the signal will come to this receiver. This pointer will be matching with this one. And this also will move to the dead slow ahead. So this is how it works. It is also having the buzzer control and all mechanical types is there. So buzzer and gong bell is going to uh, sound, and when it is replied, it will be off. Similar way, it is also working. Okay. Any doubt? No. There is a wrong way alarm. Now, what is the wrong way alarm? There is a circuit, there is a very simple circuit of the wrong way alarm. If suppose bridge is giving dead slow ahead and ECR is replying in the other way, dead slow astern. In that case, it will sound the wrong way alarm. That is the wrong way alarm. So basically the EOT lever, the diagram is made already. So EOT lever that is having the micro switches. This micro switch, all the EOT will be having these micro switches. And this is the micro switches which is going to make the contact. And accordingly, wrong way alarm, this lamp also will come and this buzzer is also going to sound. Okay. So this is the wrong way alarm circuit. Now there is a control, main engine control. I think
Sir, purpose of wrong way alarm is why?
if the breeze, if it is giving the command dead slow ahead, and suppose ECR or engine room, they are replying, acknowledging this one, dead slow astern. This is known as a wrong way alarm. Okay. That means we should not immediately, it is going to caution that we are operating the engine in the wrong order.
Okay, sir. Okay.
Okay. So that is the wrong way alarm. Main engine control. Tomorrow I'll tell you about this one because they are asking these questions also. This is the diagram I have taken from the engine governor system EGS 2200. Again, the links of marine only. Okay, from that book I have taken this one. So tomorrow I will tell you about this one. Okay, but this is the diagram for the engine control systems. Tomorrow I will be telling you about this, everything. So how the engine is being controlled from the local position and how it is being controlled from the remote position. Okay. Any doubt? Any other doubts are there in the main engine? Anything you want to ask me? What is the critical speed? What is the critical speed in the RPM? You might have seen there is a red color sticker is there and it is written critical speed. Between the dead slow and slow, in between that there is a critical speed. Correct? Why it is given? What is the meaning of that? Critical speed, generally when the ship is going from dead slow to slow, In between, you might have seen there is a marking, red marking is there, and RPM is written of the critical. Basically, your ship's structure, okay, this vibration, because this vibrates, and your propeller speed, both are going to match. And when it is going to match, this is known as a resonance condition. Due to this resonance condition, the ship is going to vibrate in the greater amplitude. And if the propeller speed is going to be in this critical speed, then there is could be the structural damage. Structural damage. To avoid this one, we generally pass this one quickly. Okay, we pass quickly this critical speed. So in this case, the ship's structure, vibration and propeller speed that match, resonance means it is matching. So a greater amplitude vibration will start. That can damage there could be a structural damage. So this is known as a critical speed. Okay. Anything else you want to ask me, main engine?
So there was one oral question regarding electronics. Why 50 ohm resistor is used in transistor?
In transistor.
Yes, why 50 ohm resistor is used in transistor, they ask.
In transistor or at the end, terminating end.
That I don't know, sir.
No, it is not transistor. It is
Uh-huh.
not a transistor. Generally, we have the electromagnetic wave. You know about this electromagnetic wave. Wherever we use this wave, okay, maybe like VHF equipment, your MF equipment, HF equipment, TV antenna, any from this antenna, the cable which is coming, this is a special cable. This is known as a coaxial cable. Have you heard about this cable? Coaxial cable.
Yes.
Okay.
Yes, sir.
Then in this coaxial cable, there is something is known as between this, the resistance, means between the ground, because there will be the screen cable. So screen is there, and between this main conductor, there has to be some ohmic value. Okay, and that is generally 50 ohm or 75 ohm, or sometimes it is 150 ohm. So the loss of signal is not there. If it is open, then there will be loss in the signal. So generally we connect a resistance here. So signal is not getting lost at the end. So this is also known as a end of resistor. This also you will find wherever we have the signal cable, like in the fire these sensors. So these fire sensors or anywhere the signal which is communication signals are there. Communication signals where we are going to terminate at the end. Generally we add this resistor. So this is known as a end of resistor. So the signal is not being lost. Second thing, this will be applicable for the coaxial cable. But for the signal cable like fire sensors and all, so there is a closed loop is maintained. Closed loop is maintained. Now, if end of resistor is not there, in that case, either the loop is broken, okay, it is it is assumed like it is an open circuit, so it will be broken, or some fire sensor when it is going to operate, it will come to know. Okay, which fire sensor has been operated, so that it will come to know. So your resistance, in that case, it will decrease from this one. So that will be something is like a shorting. Shorting will be there. Shorting means the fire sensor is operating. Is operating. Okay. And if closed loop is broken, like some fire sensor is open in between, that means closed loop is broken, so it will sense that one. So it is used for the sensing purpose. If the resistance is not there, it is not going to become a closed loop. Some resistance should be there. So that continuously it can be monitored, means current will be flowing continuously. Okay, I hope it is clear. Okay, that's it for today. Thank you very much, and good night to everyone.
Thank you, sir. Good night.